Network port scanning is the active categorization of enterprise architecture. It is the diagnostic art of interrogating network ports to map an active attack surface. When a port is categorized as open, it is actively listening. It allows access to applications, making it a prime target for entry. Conversely, a closed port is technically accessible, but it has no listening service. It actively denies entry. Here, we see three distinct network port logic gates, introducing a third state, filtered ports. These are obscured by firewalls or packet filters, causing packets to drop and hiding the true state of the machine. Because a standard connection request is often blocked by these filters, identifying architectural blind spots requires a more granular interrogation of the underlying protocol. This TCP packet header isolates the flag field to toggle specific control flags. A connect scan is reliable, but generates loud network logs. To minimize that footprint, a SYN scan stealthily drops the connection immediately after receiving a SYN ACK. Evasion requires different tactics. An AK scan is used explicitly to map firewall rule sets and identify filtered versus unfiltered ports, rather than simply finding open ports. If we use a NULL scan with all flags turned off, or a FIN scan with only the finish flag active, we exploit a protocol anomaly. Standard TCP stacks are forced to reply with an RST packet if the port is closed. We can also light up the packet by setting the FIN, PSH, and URG flags simultaneously, an XMAS scan, to bypass standard rule filters. UDP scanning operates differently. It relies on waiting for an ICMP port unreachable message to infer a closed port. Without that specific error, the scanner assumes the port is either open or filtered. Mapping a hardened network is an exercise in deduction. Match the correct flag anomaly to the target's firewall configuration to force a revealing response. Here we see Nmap, the definitive open-source standard for port scanning. Looking at the scan techniques, it executes the precise flag manipulations we just discussed, from SYN to XMAS scans. The Nmap scripting engine, or NSE, automates interactions with these open ports to retrieve service banners and version data. Nmap defines what is open. Assessment engines, like OpenVAS, define the specific CVEs on that running service. This is the Greenbone Security Assistant, the open-source fork of Nessus known as OpenVAS. By inputting a target address, it uses specific plugins to query the discovered services. These assessment engines compile packet responses into a centralized list. Looking at the vulnerability and severity columns, we can see actionable severity-ranked results, ranging from weak cipher suites to high-level credential flaws. Raw enumeration tools map the doors of the facility. Vulnerability assessment engines tell you exactly which locks on those doors are broken. Scaling localized enumeration up to an enterprise-wide discovery loop introduces new friction. Traditional ping sweeps use ICMP echo requests to identify live hosts, which network administrators frequently block. To bypass these ICMP filtering devices entirely, manual tools like Hping3 are mandatory. Here we see the TCP flag manipulation options, which allow users to inject highly modified surgical IP packets. Contrast that surgical precision with the sheer scale of Fping. Looking at the probing options, the -F flag allows Fping to test multiple IPs simultaneously by ingesting input files. This is the output of an Fping command. It rapidly categorizes IP addresses, clearly distinguishing active, alive hosts from unreachable errors. Manually entering thousands of IPs is impossible. Looking at this shell script's while loop, we see the programming used to automate target generation. The script sequentially increments the IP address, then appends it to a text file for Fping. A penetration tester achieves maximum leverage by embedding tactical evasion logic directly into programmatic automation. Successful network defense requires an intimate understanding of exactly how a target's TCP stack responds to abnormal, crafted stimuli. Testing an entire enterprise requires scripting those exact anomalies to function autonomously across thousands of nodes. Here is the complete pipeline. On the left, the raw hex of a crafted packet is generated by a bash loop. As that data flows to the right, it resolves into a clean, actionable vulnerability report. This combination of packet-level interrogation and infrastructure automation allows a single tester to map vulnerabilities across an entire enterprise simultaneously. Mastering port scanning requires owning the entire pipeline. Manipulate the packet flags, script the sweeps, and you control the attack surface.